Hello and welcome to another video. In this video we're going to be working on minimum number of removals to make a mountain array. And in this they tell you what a mountain array is, which is basically you have to have strictly increasing elements and then strictly decreasing elements, and it has to be a peak. So you can't have something like 9, 8, 7, 1, and 9 is the mountain array. So if like 9 was the mountain, the top, then you'd have to have something to the left that's smaller. So basically have something increasing, then some peak, then something decreasing. And yeah, and then return the minimum number of elements to make the nums a mountain array. So here, this is already a mountain array. So 131 is already a mountain array. So you just return, you want to return the number of elements you need to remove. So here you don't need to remove anything. And then here they tell you like this is one possibility, and then you would basically remove this guy, and one more I think. Yeah, this guy. So you'd have 3 removals. So this problem, honestly, the hardest part, like when I looked at it, I was like, you know, it's pretty hard, but honestly the hardest part is figuring out like what you need to do. And then once you figure out what you need to do, it's not that bad. And so basically in a mountain, we can kind of break down the mountain by looking at both sides of it. So we can say like, if a number is a peak, like what's the longest mountain we can have here? And then also if the number is a peak, what's the longest mountain we can have here? And then for every number, we can basically calculate this efficiently. And so let's just break that down into 2 steps then. So if our problem is, given a number, what's the longest increasing sequence we can make with it, right? And let's just get rid of this. So essentially, this is our question. So like, if we pick 1, what's the longest increasing sequence we can pick where the number is the peak? So with this 1, it would just be 1. But with like this 6, if we focus on the left side, then the longest sequence would be 1, 2, 3 elements. And so if you've done longest increasing sum sequence, this part's pretty easy to just get like what's the longest sequence we can make. And the basic algorithm for it, I can go over really quickly, is let's say these are our numbers. A few ways to do it. I'll just show the simpler one. So here we go. Okay, so essentially what we can do is we can just say, let's get another array, and this will be like, what's the longest increasing subsequence that we can make with this number? And we're going to initialize everything to 1 because everything can just be 1, right? Like you can just have a sequence of 1 number. So every number by itself is 1. Then basically what we do is basically for every single number, we can just look like what number is it bigger than and what's the biggest subsequence with that number. So we'll start here. And since there's nothing to the left of 2, so the longest subsequence, if we're going left to right, with 2 is just going to be 1. Then with 1, we check all the numbers ahead of 1. Is 1 bigger than any of them? And if there is, then the longest subsequence we can make with 1 is just one of the numbers ahead of 1, and then we can add 1 to the end of it. So 1's not bigger than anything, so this is also 1. This is also 1. And then here, so 5 is bigger than 2. So what's the subsequence we can make with 2? It's 1. So that means with 5 we can make whatever that was plus 1. So this will be 2. 5 is also bigger than 1. So we can make 1 plus 1, which is 2. 1 plus 1, which is 2. Then 6 is bigger than 2. So what's the biggest subsequence with 2? It's 1. And then we can have one more with the 6 in the end. So 2. And then the biggest subsequence, I guess I can use 2. The biggest subsequence with 1 is 1. So this will also be 2. This is 1, also be 2, and then with 5 it was 2, so now this will be 3. And the basic idea is if a number is bigger than something else, then if y is the end of a subsequence, then we can just say, well, we'll just take that and add x to the end, right? And that will make whatever the y sequence was plus 1. So with this will be this. With 2, 2 is bigger than, not bigger than this, it's bigger than this, and bigger than this. And this is both 1, so this is 2. 3 is bigger than this 2, so that's going to be the biggest subsequence. It's also bigger than this 2, but this is like going to be 1, 1, and the biggest one is here, so this will be 3, right? We can make 1, 2, 3, and then with 1 there's nothing. So you make this left to right, and then you make the same thing right to left. So basically the same thing, now you just traverse the other way. So we'll start over here. So like 1, there's nothing to the right, so it's just 1. 3 is bigger than 1. I'm not going to draw these arrows just to make this faster. 3 is bigger than 1, so we can make a subsequence of length 2. 2 is bigger than 1, so we can make a subsequence of length 2. 6 is bigger than 3 and 2, so we can make a subsequence whatever those was plus 1, right? 1 through 6. So this will all be 3. This will be 3 as well. And then this will be 1, 1, and 2. Okay, so basically these arrays are what's the biggest subsequence I can make going left to right, and this is right to left. And then for each one of these, as long as the subsequence you can make going left to right and right to left is both greater than 1, right? So the number, left number has to be greater than 1, and right has to be greater than 1, because you have to have a mountain, right? So if I have like 9, 8, 7, even if I have this long sequence, 9, 8, 7, 6, 5, and so on, if I have nothing to the left of the 1, that means this is not a valid mountain. So I need this number, whatever I choose to pick, the peak, to be at least linked to left to right and also right to left. And so if that's the case, then what's the actual like mountain I make? So the mountain I make is just the left value plus the right value minus 1. Because basically left is the longest increasing subsequence up to the number, right? So like if we have 6, it'll be something, 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 6. And right to left will also be 6, something, 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 something. So we're counting 6 twice. And so the actual mountain will be this. So then basically all we do is we just go through all these values, and if for a number, both of these values are not 1, we add them together, we subtract 1, and that's the length of the mountain. And then the number we have to remove is just length nums minus length mountain. And whatever gives you the least there is your answer. So it's just basically a longest increasing subsequence left and then right. You can also do this doing binary search if you want, but yeah, the main hard thing is just figuring out like this is just the longest increasing subsequence in 2 directions. Okay. And yeah, so the answer here would be 6, because for 6, or you can use 6 or actually no, 6 would just be strictly the best, I think. Let's see. Yeah, because 6 has a 3 and a 2 minus 1, so this would be a mountain of 4. Is that right? I think I actually screwed this up. Oh, right. 6 is actually at index over here, right? So 6 is at index 4. So at index 4, this is going to be your answer. So it's going to be 3 plus 3 minus 1, which is a mountain of 5. And then since we have 8 numbers, we're keeping 5, removing 3. So that's the answer. So we just basically do 8 minus 5 here. And so 6 is the best peak. Yeah, so let's take a look at the code. Pretty simple. So you just make an array of lefts and rights like I showed in this picture. And then it's basically you just fill them all up with 1s, and then you go left to right, and you just check if my number is bigger than the number before, right? So for every number going left to right, go through all the numbers before it. If my number is bigger than the one before, then the longest increasing subsequence is either what I currently have or the one with the one before plus 1. And the same thing with the rights, except you traverse backwards. And then for every single number, we just check this has to be true because it has to be a mountain. It can't be going straight down this way or straight down this way. And if that's the case, then it's basically just the length of nums minus left plus rights minus 1, because we're counting this mountain twice, so we have to subtract that as well. And yeah, so this is going to be n squared. And I think there's also a binary search one, and if you want to look at that one, it's basically the same solution to the longest increasing subsequence. That's like a little bit trickier, but yeah. So yeah, basically that's all there is to this problem, is just longest increasing subsequence 2 directions. And I do think it's not super easy to figure that out just by looking at the problem, so that's a hard thing. Like once you recognize like what you need to do, actually doing it's not that bad. So this is n squared. And n space, because we just have the left and the right and the original array. So yeah, hopefully this is helpful. If it was, please like the video and subscribe to the channel, and I'll see you in the next one. Thanks for watching.